So let's see. Let's see. Last week we basically introducing the root and radicals, right? Root and radicals. We basically use the homework part to understand radicals. We focus on that part, how to simplify the radicals, right? When there was multi variables, how to get rid of them and get out of them. Just keep this in mind. Most of the time we say x square root equal x. We already say x greater or equal than 0, right? But if they are not mentioned, let's say x can any numbers, you need to add absolute here, right? Just like say here, you maybe see my something like say -8 square. This is not equal -8, right? So it's actually needs absolute. Actually, they are equal 8. It's like 64 square root equal will be 8, right? So it's not exactly equal, they are -8. So you need absolute actually equal 8. So like 70 this square root, this kinds of square root. If they didn't mention say y greater or equal than 0, if they mention x, y greater, you can direct like this way, right? But if they didn't mention that y greater or equal than 0, you have to add absolute on top of it. Okay, right? Just keep this in mind. So for the cubic root, just like cubic root, here don't any negative number, positive number is fine. The underneath this radicand, this a didn't require x have to be greater or equal than 0. They don't require this one. X can be any numbers when the radicand cubic root, and if they are even number, it's just like I say, this is even numbers. If they are even numbers, you have to make sure the inside here x should be greater or equal than 0. When the n is odd natural number, so they don't require x have to be greater or equal than 0. So x can be any numbers, any natural number or any rational numbers. Okay, so let's just keep in mind even number or odd numbers. But we didn't go that far right now. We didn't go that far. We mostly focus on square root or cubic root. We didn't go something like so far. We didn't use so many, something like we didn't go that far. We just mostly focus in these two kinds of situation. All right. Just again, make sure when they are square root, the inside should be like under the square root kinds of radicand should be greater or equal than 0. So some of the cases here, you needed to define how, when there was positive number or greater or equal than 0 number, no less than 0. Okay, so quickly see some other examples, something like this one. Right now we go more complicated case. We know the square here. When suppose x is any number, we have to do like this way. So 4x squared, we know that's one, but when we simplify it, it's inside we can get it like this, right? So we suppose x is greater than 0. So you can just go back, right, like this. Same to like this one, right? So we can introduce a more complicated case. You can see underneath here actually became the polynomial kinds of stage. So it's actually same, right? So let someone describe like this way. So it looks like they cannot, but we know that one, this part can be rewrite into x plus 3 square, right? So it can be right like this, right? So it means we will face a lot of similar situations like this way. What should we do? How we should do? Okay, Okay, so we're not just facing about something like a number 216, how to make the simplified case. So this one you guys can quickly do like this way. So we will facing something like the polynomial in the radicand. How we do that, right? How we do the addition, how we do the subtraction, how we do the multiply, how we do the divide, when these kinds of cases. How they do the addition, plus, minus. So this actually two situations in time and divide, right? When we do these kinds of operations, how we do them? How we handle them? When they became equations, something like radical x equal 6, when they are equations, how you find their solutions? That's our objective, right? When you have these kinds of radical kinds of in your equation, how you handle that? Right? That's what we have objective to move to, right? So let's move on some more specific examples. So everyone can do this one, right? Simplify. Oh, sorry, I do this first. So everyone can do these kinds of situation, how to simplify it. Just keep this in mind. Simplify cases, just like say what I told earlier, say, if less a greater than b, a, both of them are positive numbers, they can break it down a, right? And then when they divide, they can also break it down like this, right? When there was like terms, suppose here is 4, here is 7, so they are like terms. They can still be combined like this way. When they was minus, they can still 7 minus 3, they can still go down like this way, right? Right. So basically, this part simplify, we use the rule is right here. Right here. Okay, so simplify case, actually we use the homework to review that part. So when we do the addition and subtraction radicals, how we do that? Actually, this is just consider about just like what I will right now talking. So 7 square root a minus 3 square root a. This one actually easily to combine, right? Because so like you consider this is a variable. Because of this part, just like a, right? So you can see this part, other than coefficient part is different. The rest of the part is exactly the same. We consider this is like terms. We learned these like terms before, right? So only, so when we do these kinds of addition and minus, the like term part was not changing. The coefficient part do a proper operation, right? Like 7 minus 3, so you can got 4 here. So actually here, so actually a lot of people just one step, we can already got this one. Just like earlier we talked about, say, they are like terms. So here you can quickly get here. They are like terms. 9 minus 6. You just do coefficient part, do the calculation. The rest part, you don't do any calculations, right? Like 9 minus 6, so you can get 3 here out of here. Okay, so I will skip this number part. Maybe we pick one of them to talk about quickly. Okay, let's pick this one, this one. So you can see this one, actually, first we do proper simplified situation. So 7, so square root is 12. Actually, you can, is 4 times 3, right? So you became 4 times 3. So here became 7. So actually here became 14. Here 2 take it out, right? The square root 4 equals 2. So you got 14 square root 3. What about second part? So here is 25 times 3, right? So here it became 5 square root 3. So in this situation, you can see they have the square root 3, actually square root 3 equal what? Right? About something like this big number, this irrational number. Irrational number. So you can actually say here is equal 9 square root 3. You can see this part is considered like terms here, right? Right. So we will extend this one to our with the variable station, like this number, like these examples. So here it became, suppose x is greater or equal than 0, all right? So here it became 5x squared square root x, right? And what about the right part? Here it became x squared square root x. So these two actually is like terms. We can combine a little bit further, right? So it became 4x squared square root x. So that's it. That's it. See cubic root. This is the cubic root. How it looks like. Okay. So here we needed to transfer something. Like say this is 8x cubic times x and cubic root. And also 5 of them, right? Find is have 5 of them. What about this part? This part here became what? 27x cubic times 2 and cubic root. So you can see the internal variable x. Here we can rewrite it 2x cubic, right? So here became, this part can take it out, Actually here cubic, so you can see here is 2x and cubic root x here, right? We know that 27x cubic here actually can rewrite it 3x and power cubic, right? So here it became 3x, right? All right, so can we be further combined? No, but we can rewrite this one here, it became 10, right? 10x times this one minus this one, we already simplified. So adding and the subtraction radicals, similar to do the like term combinations. All right. So internally we need to do some proper transform, make sure, try to make it more simplified as needed. Okay, so let's see some more examples. When there was multiply, when we do the numbers, like say, when we simplify, say number 30, like this one, we know this one can be transferred into 16 times 2, right? So you can got here. What about you do backwards? You can first, you put a 4 inside, right? And it became 16, and 16 times 2, you get it here. So actually here, go back to see, just like A times B, actually you can get it. Right? So we do these kinds of simplified case numbers, simplify these radicals. We can do this progress. You can do the backward, right? Backward. The same. When there's 2 radicals, when they time together, you can do backward and do backward, just like this one. You can go this way. You can also go that way, right? Right? When you say A over B, you can transfer into, you can go this way, also go backward, right? So they have same situation here. Same situation. All right. So let's quickly see multiply situation. Multiply actually is this situation. We do backward is this situation. So like this one, so you got the 21, because inside they can time together, right? What about this one? So you can 3 times 3 the inside, so you became 9, so you can take it out, it became 3, right? What about this part? So you can 3 times 15, so you can transfer 9 times 5, so you can transfer into 3 square root 5, right? You can do backward and frontward. What about this one? When the coefficient in front, what do we do? So outside part is time together, inside time together, right? Okay, so let's the coefficient, just like say 2 square root 3 times 3 square root 2. So this is just like a 2 times square root 3 times 3 times square root 2, right? So you can do a proper adjustment. You can 2 times 3 times square root 3 times square root 2, right? So you can go to here is 6, but inside it, they can combine together, they become 6 as well, right? So the same here situation. So 2 times, you can do a proper adjust, right? So you can go to here, go 10, here square root 6, right? What about this part? So we can, inside actually they can time together, became 12x power 4. So we just need to simplify here, right? So became x power 4 times 3. So here became 2x squared times square root 3, right? So this one, just one by one, one time, one term, one radical times the other radicals. This will be well to handle. So you guys can definitely do this too, all right? Sometimes like this one, when they square, when they do the square, actually just 2 number of length, right? 2 exactly number of length. So you can do 3 times 3, you can go 9, here square root times square root 2, you got 2, so you got 18 out of there, right? What about cubic root? So make sure they are the same. Make sure they are the same here. You can move inside. So keep as it is, right? So the rest was timed together as well by itself. So cubic root here. So here became 4 times 2 times 9. Let's make here. So here is 8. So it means 2. So here 8, we divided 2 power 2 cubic, right? So here take a 2 out, 2 cubic root. So a 2 can take it out, right? And here is cubic root 9. We cannot take this out, right? Because here cubic root is square root 9. We can take it, become 3, but it's cubic root without change. Okay, so what about one terms? One term have one radical. The other term have two terms, like this different situation, like this situation. You can see the first have a radical. Second one actually 2-term radical. So this method is the same as what we're doing. This is just like A times B plus C, right? So we distribute inside. Okay, same situation, distribute inside. So let's see the number 3A here. So this one actually is distribute inside, right? Minus square root 2. Time here, sorry. So here, so this part you can go to 5. What about second part? Square root 10, right? All right. So we go to the special situation, like this one. So what we do this one? We also do equals. We do the same. Distribute inside. First, distribute inside. Don't do any changing. Just distribute inside. Don't copy wrong. All right. I thought a lot of people actually happen is because when you do these kinds of distribute inside and skip steps, sometimes skip step, if you very familiar process, that's fine. But sometimes you are not familiar, just copy it first. All right. So like this one. So right now it's easy to win. So under radical, we can be 3x squared, right? What about this one? So 5 put in front, right? Put in front. So here inside is 3x times 3. So here became what? X square root 3, right? And here is 5. This is 9, can take it out. 9, 3 times 3, 9 square root became 3. 3 times 5, you can go 15 square root x. So that's it. So they cannot further combine, right? They cannot further combine. They are not like terms. You can see they are under the radical is square root 3. Here under radical is square root x. They are not like terms, so cannot be further combined. So that's it. Just keep it as it is. Okay, so see the third student. That's 2 terms times 2 terms. What do we do? Exactly like what are we doing? Do the FOIL methods. FOIL methods. So this is too busy right now. I just clear first. So see this one, see the number C situation. What do we do in this 2 terms times 2 terms? 2 terms, there's 2 terms times 2 terms. So exactly use the Fourier methods or rectangular area methods. Area methods, all right? So as earlier as what are we doing here? So we need Fourier methods. You guys know the Fourier methods. First, second, third, and the last one, right? So you can generate 4 terms. Okay, so I just keep here, make sure I'm not confusing. Okay, so you can see this part is 4 parts. So right now we simplified. So here it became 3x. What about this one? Square root 2x. What about this one? Square root 6. What about this one? 2. So you can get this part. Okay, so this situation. This situation, you can see this A minus B, A plus B. You guys were familiar with this one? I believe you guys were familiar with this one, right? So here actually became square root 5 square minus 7 square. So here became 5, here became 49, here became negative 44. Interesting, huh? Right? So we use the same method as we learned for the polynomial kinds of multiply. What about this part? Something square. So you guys definitely remember this part, right? A squared plus B squared plus 2AB, right? Same here. First square, second square plus 2AB, right? So here 7x plus 4 plus 4 square root 7x. That's it. That's it. So the same situation used in our earlier knowledge, right? Just a little bit different. Just is they have some radical, just like simplified progress, we use the radical information. So we do the multiply. When we do the dividing, just like do the dividing here, we know that when A divided B, you can transfer do like this, right? So we can do backward, right? When I do divide backward, make sure they are, this number here is the same. When they both square root, you can put both cubic root and then combine into here, right? They don't need the changing. Okay, all right. So same, so backward. Earlier we do for this word. When we do the simplify, we can do this word, we can do backward. Oh, quick example. Make sure here is in same, the same kinds of square root or cubic root, they are the same. If they are not, you cannot do that progress. So like this one. So we do actually we transfer 14 over 2, right? So you can square root 7. The same here is 100 over 5. So you can got square root 20. So we can do further simplify. Right? What about this one? So big one. So first, so you can actually do 4x squared, right? So you became 2x. Suppose x is greater equal than 0 situation. Okay, so what about this situation? They have different. What about this situation? They have different. So you can transfer first. Okay, to transfer. So here we can square root 4, right? 7. Or we don't do like this way. We can do say both top and bottom, both times square root 7. Right? So bottom is became 7, right? The top became. It means we make the denominator rationalize. You know that this is not irrational number. Square root 7 is irrational. We make it irrational, rationalize. They call rationalize denominator. We know that square root 7 is irrational number, right? We make it rational. Irrational, make it irrational. Make irrational number 2 rational. We call rationalize. Okay, let's see the number B here, this situation. So we can do like this. We know the bottom part, we can transfer into 4 times 3, right? right? So both top and bottom times square root 3. So here it became 15, here it became 2 times 3 became 6, right? Right? Same here. So we can do proper transform first. Top is 1, right? Here it became 18 square root 18x. All right, so we both times 2x. All right, both times 2x. Why with 2x? Let's think about this one. So you can become 36x square root. So it became 6x. The top part became 2. So the bottom part is rationalized. It's rationalized, right? Okay, so I believe you guys can do this one quickly. So let's see a very special situation. When their bottom have two terms, how we make their rationalized? Just keep in mind here, earlier we do some special situation. I think last slide here we do a situation like this one. This is very good kind of example. You can see when the number times another number, just like a plus b, you times a minus b. So equals a squared minus b squared here, right? That's very, very good example. So let's go back to see this one. Let's go back to see this one situation. What we can make it rationalize. Okay, so see this situation. So we cannot just times square root 3, right? Or square root 2. We cannot do that. So what do we do? So we try to make it rationalize. Actually, this situation is we make it like a 4 minus square root 3. Do you see what's the difference between these two? This is a plus b. This is a minus b. So of course, on the top part, we do the same. All right. So you can see when you factor, this can factor out, right? Factor out. But what are we changing here? The bottom part, the denominator part, what are we changing? So he became 4 square minus square root 3 square, right? Right? This is a plus b, this is a minus b. So you both here. So the top part here, the top part, we don't need changing anything here, right? We just copy. So the bottom part actually changed into 16 minus 3, right? So it became 13, right? 16 minus 3 became 13. 2, 4 minus square root 3. So you can see the denominator actually change into what? Change into a rational number, not irrational, right? Okay, so see this one. So this one, what do we do for the second one? So both our top bottom actually we times 1 minus square root 3, right? 1 minus square root 3. Okay, so what they are changing into in the, so 1 square minus square root 3 square. Top, we don't need changing anything, right? So 1 minus 3, so became negative 2. Negative 2, 2 divided negative 2 became negative 1, right? So actually change for square root minus 3 and minus 1, square root 3 minus 1. That's it. You see, interesting here. These kinds of situation actually change into this. All right. So let's see last two examples before we end today. So this one, how we do this one? So both top and bottom times what? Called conjugate. Actually, we give a name of conjugate. This is a minus b. We say became a plus b. All right. Did you see? They are plus b, right? So the bottom part actually became square minus 1 square, right? The top part we do some, we distribute it inside. So first is 5, square root 5. So here is 1 square root 4 square root, so it became 5 square root 5 and plus 4. Right? What's the bottom? 5 minus 1. 5 minus 1 became 4, right? The top 9 plus 5 square root 5. See, we make their denominator became rationalized. What happened if they are including these kinds of situation. All right, so we do the same, both top and bottom. We change into 1 minus square root x, 1 minus root square x. So what are they changing? What are they changing? So x denominator became 1 minus x, right? Square root x squared became negative x. So the top part. That's it. That's it. So you can see if there are any number put here, you at least there's no square radicand in the denominator. So this part is super critical for us for near future to make the denominator become rationalized. Okay, all right. So that's all for today. I know we have 10 minutes delay here, but I think we worth it, right? We take pretty long. We don't have the time break. I'm sorry for that one, but that's all for today. And just one more thing to remind for everyone, all right? Don't forget to sign up a math competition for next week. You can go to the website. I believe the family group in the WeChat, everyone was told ask to register for next Saturday, 7:50 to 9 o'clock. Just 1 hour, 1 hour and 10 minutes. Actually, 10 minutes kind of earlier to make sure everyone set up. So have 1 hour kinds of math competition, similar like AMC8 text and very quick kinds of competition. Make sure you guys have opportunity to show your guys talent. Sounds good, everyone? I make sure I help you guys. And also have a reward. I think they put a very good reward for maybe earlier they say try to give everyone a good trophy. So make sure guys go get it. Go get your beautiful trophy. All right, sounds good, everyone. See you next week.
Is the competition only for middle school?
Everyone, for everyone,
okay.
Everyone like to go, and everyone have opportunity to go. But we will separate kinds of something like say 10 to 12 grade in one level, or something like say 7 to 9 level in second grade level, and the rest in the lower level. Just like you go to the same kinds of competition, but we separate it by the age or by the level what the initial supposed to in, and to give different people in different level and give their rewards. I don't like you guys saying we are in the 7th, 8th grade, but we don't like compete with the 10 to 12 grade, right? So they are higher level. You are in the 7 to 9 kinds of middle school level. Just middle school in the middle school, high school in the high school, maybe use the same kinds of competition kinds of topics, but the reward will be go through by your age. All right. Hope I see everyone there, and see you next week. Have a wonderful week. See you next week.
Bye. Thank you.
Okay.
Bye. Thank you.